I hope it's recording. Okay, so we're starting the lecture now, all right? As I said earlier, I'm not sure if this room is free all the time. So if you get kicked out, you have to go back to our room, okay? So this is the example we started last week. A pitch roofed frame, symmetrical, the geometry is symmetrical, and subjected to V and H. And we said we have two, using the rules, we have 5 possible hinges, but only 4 are needed for total collapse, okay? And we have 2 independent mechanisms, sway and part sway. Yep, and I think we covered the sway mechanism, all right? And we got H equals 40. This is the sway mechanism. We have 4 hinges. So it's a total collapse mechanism. That's a sway. Then we covered the part sway mechanism, and I did explain how to obtain the angles. Was that clear last week? Yeah. So this is the part sway mechanism. So only part of the frame is swayed, right? And again, we use this construction geometry to obtain the angles, the angle beta here, right? And we got, from this, we got V equals 35 when we use external work equals to internal work here. Okay, the external work is V times 8 theta, right? And then we have got the MP theta at each of the joints here. So we have MP theta, MP theta, MP theta, and then at joint D we have MP. I should show here MP as well. Sorry. Okay. Then we have MP theta, MP theta here. This is theta as well. Okay. And finally, MP beta at E. MP beta at E. And then we determine beta from geometry. We determine beta as 4/5 theta. Sorry, beta, yes. Okay. So that gives us, when you substitute the beta everywhere by 4/5 or 0.8, it gives V equals 35. And I think we got to this point last time, okay? So we have covered the 2 independent mechanisms, and then we are going to combine the 2 together. That's the sway plus part sway. So we're combining this one here, right? And this mechanism. When you combine the mechanisms, when you combine these 2 here, the sway and the part sway, the hinge at B is going to cancel for the same reason as we had with the rectangular frame, if you remember. Okay, because the column and the beam here, this member and this column will rotate in the same direction, clockwise, and therefore the hinge at B will cancel, and we are left with the hinges at A, C, D, and E. So this is the combined mechanism that I'm going to cover here, okay? So I want you to bear with me. We do it slowly, and I'm going to explain it. So this is the combined, okay? So combined, so this is the original frame. And when you combine these 2 together, the sway and the part sway together, if you combine these 2, you can see that the displacement at this end will be larger when you put them together, okay? So you've got the displacement at B is smaller than the displacement at D because of the principle of superposition, right? Plus, as I said, the fact that the hinge at B will cancel because this member and this column here are rotating in the same direction. So you have cancellation of this hinge. And you are left with 1, 2, 3, 4 hinges, which is what we need for total collapse. It's a similar thing that we had before when we did rectangular frames, when you do the combination. Is that clear? So let's do it. So I'm going to do it slowly. Don't draw it yet, just in case I make a mistake. So I'm going to try and do it slowly. So we have got this, okay, and then we have got the hinge, the displacement here will be larger, okay, something like that. And then we have got something like okay, something like that. Is that clear? Yeah. And what we have hinges there, 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 and there. Is that clear? And that's the 4 hinges that we need. Okay. The question now is to find the relationship between all the angles so that we can then do the external work and internal work. All right. And you can start wherever you want. You can start from this side or from this side. So I'm going to keep the same, to be consistent. So I'm going to call the angle here theta, right? Now, so this is theta as well, okay? And we need to find what this angle beta is, right? There are 2 ways you can solve this problem, right? Either you determine the angles from the geometry, or you use the principle of superposition. I'm going to do both, so to show you that it's exactly the same, okay? So I'm going to do it from the geometry here, show you how to do it, and then I'm going to show you how to use the principle of superposition. All right? Is that okay? Right? So how do you find this angle beta? The construction in this case is slightly different than what we did here with the pathway, because with the pathway you extend this AC, you extend BC, and you extend the column and the intersection at point I, and then you join to the new position of the joints. Do you remember this last week? Yeah. For this, in this case here, it's slightly different. So the way you do it is you actually, if I call this A, B, C, D, E, so we have B dash, C dash, D dash. All right. Okay. So what you do, you extend from A to C, right? Can you see here? You draw a line. Don't draw, because as I said, I'm just doing it here to show you how it works. Okay. Then you extend the column, ED. It gives point I here. Is that clear? Yeah. So you extend. Oh, sorry, I made a mistake. I'm going to do it quickly here. Sorry. That's why I said don't do any here. Okay. So you draw a line from A to C, sorry, from A to C. Okay. Then you extend the column here, column ED. It gives point I. Is that clear? Yeah. Then you join to the new positions. Is that clear? I repeat. So this is the original frame, A, B, C, D. Okay. This is the new positions, B dash, C dash, D dash. You join A to C, extend it, and then extend ED. It gives you a point of intersection I. You join I to C dash, to D dash, and then from C dash to A, right? And we have got now this geometry here. And we start by saying that the angle at A is theta. Is that clear? So if the angle at A is theta, what do you think the angle here is? Why? Why is it theta? Yeah, exactly. If you remember what we said last week, if you look at triangle ABC, triangle ABC rotates to AB dash C dash by an amount theta. Is that clear? Yeah, because the member does not deform. It's a rotation. Yeah, there is no deformation of the members. They stay rigid. The members don't deform. So therefore, we have a rigid rotation of triangle ABC. Okay, so it rotates by angle theta. Then IAC dash is an isosceles triangle. Do you agree? Because we have the same length. Is that clear? So you have an isosceles. So therefore, this is theta. Good. Then what? What can we say about the angle here? Again, because we have triangle ICD rotating to IC dash D dash by theta. Okay? So now the only one left is this angle beta. Any questions? So how do we find beta? So I'm going to draw, this is a horizontal line here, okay? My drawing is not very good, so I apologize. What can we, what we can do, we can actually draw, can you see here, I draw a horizontal line, yeah? And let's call this point here N. So we have a similar triangle, INC is similar to IEA. Can you see that? Can you see the big triangle? IEA is similar to INC. Agreed? Yeah. So we have IN over NC is IE over EA. Okay. IN, we don't know. NC, do we know NC? 4. Look, this length is given. Is it 8? Sorry, 8 meters. Yeah, so we have 8 equals IE. IE. IE is IN plus NE. Okay, is IN plus NE. What is NE? Seven. Agreed? Divided by EI. 16. Okay, good. So that's it. Okay. So now we have 16 IN is equal to 8 IN plus 56, isn't it? 8 times 7. Okay. So we have 16 minus 8. 16 minus 8 is 8. So we have 8 IN is equal to 56. So IN is 7. Okay. So IN is 7. Okay. So that's it. That's what we need. So IN is 7. Therefore, if IN is 7, I need ID. ID is 7 plus 2, 9. Okay, 7 plus 2i. Okay. Then what is DD? Then what is DD dash? DD dash is 5 beta. It's also 9 theta. So therefore, beta is 9 over 5 theta. 9 over 5 theta. Okay. If you go back to this here, if you go back to the now using principle of superposition, the angle here is theta, is the same. Yeah. the angle in the pathway beta is 4/5. Okay, so 4/5 plus 1. What is 4/5 plus 1? 9/5. Exactly the same. Okay, so I put here same answer using superposition. In the future, if you have got an exam question or whatever, you don't have to do all this. Yeah, you need your mechanism, and you use principle of superposition to get the your angle directly, because you have already done it. Is that clear? But I just wanted to show you that you can get the same answer from the basics, from the geometry, or using principle of superposition. Is that clear? Okay, so we've got beta here. Now we can do the external work, internal work. We have V here, and we have the horizontal force H. Okay, so we have external work. We have H. What is this displacement? BB dash. Sorry, 5. Yeah, plus V times displacement 8 theta equals, we have MP theta, we have MP theta, MP theta, MP theta, MP theta, and MP theta. Okay, so we have MP theta at A, we have at C, we have MP theta and MP theta. Okay, so at C we have MP theta and MP theta. So we have MP theta plus MP theta. This is at C. And then at D, we have two members. At D, we have two members. We have MP theta and MP beta. This is at D. And finally, at E, we have MP beta. Have they got a lecture here? Okay, so we have 5H. What time is it? I have a feeling they've got a lecture here, or not, maybe. 8V theta. So we have 1, 2, 3, 4 MP theta plus 1, 2 MP beta. So I can substitute for MP theta plus 2 MP. Beta is 9/5 theta. Now I can simplify the theta. So I have 5H plus 8V equals 2 times 9, 18, 18, 5 times 4, 20, 20 plus 18 is 38, 38/5 MP equals 38/5, was it 90? 50. So 5 divided by 10, 380? Yeah. I hope it's correct. I haven't got the answer with me, so I guess it's correct. Okay. Any questions? Any questions?
Excuse me, sir.
Yeah, 1 minute. Yes.
Sorry to ask, with respect to the attendance, what have you decided? Will you do it or should you do it?
Don't worry, I'll do it. I have access to the whole class, and I can do it as a bulk for the whole. Don't worry. Don't worry. 5H plus 8, V equals 380. Is that okay? Any questions? Any questions? So, in summary, yes. No, you can use superposition. Yeah, that's fine. Yeah. Okay, summary. Can you keep quiet, please? There is too much noise. Please. Okay. So for the sway mechanism, we have H. What was it for the sway? Was it 40? H equals 40. For the part sway, we have V equals 35. and the combined, we have 5H plus 8V equals 380. And these are the mechanisms. Sorry, these are the results for each of the mechanisms. Is that okay?
Yeah.
Okay. Now, what do we do with this? Now we are going to draw the interaction diagram for this frame. Interaction diagram. Can you give me what is for H equals 0? What does it give for V? H equals 0, 384 divided by 8. 7.5. 40, thank you, 47.5. And for V equals 0, we have H 76. Thank you. So I'm going to now do the, I'm going to build the interaction diagram for this frame, okay? Normally, as I said before, you really, try to do that on a graph paper nicely. So we have V for the vertical axis, H for the horizontal axis. And I'm going to use a scale. The maximum value I can see here, V47, say 50, so 50, 10, 20, 30, 40. Okay, then I'm going to choose a scale for the horizontal axis. So we need up to 80, so I have okay, so this is the scale. This is the scale. All right. Now we have H equals 40. Can you please follow what I'm doing? So we have H equals 40. Is this one? So this is H40 sway. All right. Then we have V equals 35 for the part sway. V equals 35 for the part sway. So we have 35 is here. This is part sway. Then we have 5H plus 8V equals 380. I have 2 points here that I can use to draw the line. So I have H0, V47, 47, 45, 46, 47.5, about there, 47.5. So I got this point. And then I have 76 for Z0, 70, 75, about there, 76. And then you join these two together. And that's it. Okay. So these are the three mechanisms. This is combined. So we have 5H plus 8V equals 380 combined. Okay. Any questions? So now we've got this point. Let's call this P, Q, R, S. Right? So anything inside is safe. Anything inside here, safe. Anything outside is unsafe. And then on the borders here, we have got the actual failure mechanisms. So PQ represents the pathway mechanism. QR represent the combined mechanism, okay? And RS represents the sway mechanism. Is that clear? Yeah. Then we have the points of intersection. Q represents, what is Q? It's an overcollapse. We have got path sway plus combined together at the same time, okay? So we have path sway plus combined together. So it's an overcollapse. Why is it overcollapse? Because you end up with 5 hinges. Okay, if you put these two together, if you look at the, if you go back to the mechanisms and you put the combined and the pathway together, you get 5 hinges. Okay, which is an overcollapse. And what we said an overcollapse means the frame has already failed anyway. So it's a theoretical mechanism, but it doesn't exist in practice. But in theory, we can see that it's a possibility. Yeah. Sorry. In theory, it just means you have an overcollapse. No. It's just a theoretical possible mechanism. Okay. Because in practice it will fail already. It has already failed. Okay. It has already failed. Okay. We can find the. Okay. Let's do. And R will be the combination of sway and combined. Sway plus combined together overcollapse. All right. Now the coordinates, if you want to find Q, this one here, you need to put V equals 0 into this equation. V equals 35 into this equation. Okay. So we have V is 35. So we have 5H plus 8 times 35 equals 380, which gives, what does it give for H? 380 minus 8 times 35 divided by 5. 20. Yeah, look, my drawing is not even to scale, and look. Okay, so we have Q, so therefore Q is 20 and 35. Okay, so the coordinates of Q are 20 and 35. Similarly for R, we have H is 40. So you have 5 times 40 plus 8V equals 380. So which gives V equals, so I'm guessing it will be around 25. Around 22.5. Okay, 23, 22.5. So we have R is 40 and 22.5. So this combination of horizontal force of 20 kilonewtons and a vertical force of 35 kilonewton will give us a combined mechanism and a path sway mechanism together overcollapse. Okay, and the same here for R. Okay, this combination gives a sway plus combined together, and any combination here will any combination of loading, we can determine what's happening. Okay, so for example, if you have H 20 and V 10 kilonewtons, you have got a safe, the frame is safe and there is no failure, there is no collapse. Okay, so this is again, I repeat what I said last week. This diagram is very useful when you are designing this kind of frames. Okay, because it tells you exactly what combination of loading will give you what. Is that clear? Yes. The application is, as I said, in design. So if you know what the loading is, you can predict what your frame will fail. So if I have a portal frame, then if I don't want the frame to fail, then I have to avoid any load combinations there. And all my loading has to be within inside this here. Okay? Otherwise, it will collapse. All right? So practically, this is what you need. In design, you want your structure not to fail. Right? So you have to go for any combinations within this area. Sorry? Acquiring what, sorry?
The section of the members is asking how to acquire.
Oh, the section, that's the next step. Because once, if you know the loading, you get the bending moment diagram. When you have the bending moment diagram, for each member, you know the bending moment diagram, then you use the design. Because you know the load and you know the moment. So you have the two, okay? Then you do what we do. You see, if you have a beam, if you know the load and you know the bending moments, you can design it, isn't it? It's the same here, right? This gives you the load the safe combinations. Then you do your bending moment diagram, and then you can design it, and you get the sections. Okay? Any questions? We are not doing design, but that's how you should. That's how you will do it in practice. All right? This is plastic design. Okay? In other words, if you take any load combinations on there, you are taking it to the limit. But in practice, what we do, we always use a factor of safety. That's how you do it. Okay. Any questions? Anything at all? Okay. So we've finished this one here. So let's do a different example. Okay. If I give you the same example, this one here. Okay. If I give you the same example, but this time, the load H is applied at D, at the other side. Okay? So if I give you the same frame, but this time the load applied at D, what will change? What will change? Any idea? If you apply the load, if the load is this time is not at B, but applied at D, what's going to change if you apply the load at this end? Will the sway change or not? If the load is applied at this end, it will change. Why? Well, no. If the load is applied here instead of there, if it's applied here, it's going to sway in the same way, isn't it? So what's going to change? Is anything going to change here? What's going to change? If H now is there, will this equation change or not? No, because it's still H times displacement, which is 5 theta. So this mechanism, no change, right? If the load is applied at the other end, okay? If now we look at the path sway, please pay attention with me, okay? If now with the load is not applied at this end, but at this end, what's going to change here? In this case, everything here is the same. Yeah, everything is the same, except that on top of V times a theta, you also need to add H times 5 beta. Is that clear? Yeah. So if you have the H at the other end, you need to multiply the H by the corresponding displacement. This is what I said last week. It's always the load or the force times the displacement where the force is applied. Clear? So it will be H times dd dash, which is 5 beta or 4 theta. Is that clear? And the same thing will happen here. where is the combined? If you go to the combined mechanism, you get exactly the same happening. It will not be H times 5 theta. Look there, please. It will not be H times 5 theta. It will be H, if H is here, H times 5 beta. H times beta. Is that clear? Right? Any questions on that? So what I'm asking you, please, I've got the solution. I want you to do this on your own, and I'm going to upload the solution by Thursday. Can you do that, please? Redo this example with H applied at D. And then complete the problem to the end. Is that clear? Can you do that, please, for next time? Yeah, as a tutorial, extra tutorial question. And I will upload the solution so you can see how you did. Is that okay? Yeah? Any questions? Yeah, I've done it for you. Basically, you just need to put it on paper and just check it. Is that okay? Okay. So let's do the new question. So this is the second question, okay? The previous question, we did a symmetrical frame, okay? We had a frame which is the geometry was symmetrical. So I'm going now to show you how to do it for a frame which is not symmetrical, and also where the MP values are different. So the frame is not symmetrical, and the MP, the plastic moments, are different as well. So we have everything, all right? Then you can see how the geometry works. Okay, so example number 2, if you want, we have got this here. Let me draw it. It's not to scale, all right? Okay. Wait a minute. I'm just thinking which one I give you, because I got 3 examples here. Okay, yeah, so we'll do that one. Okay, now the frame is not symmetrical, as you can see, and also we have got different values of MP. And again, the question is to find the mechanisms and also draw the draw the interaction diagram. So what is M? 1, 2, 3, 4, 5 again. N is 3 plus 3, 6 minus 3, 3. The number of the number of independent mechanisms is the difference. 5 minus 3, 2 independent mechanisms. So we have sway and part sway. And the number of hinges needed for total collapse is N plus 1, 3 plus 1, 4. So we need only 4 hinges, which is exactly what we had in the previous example. So the first one is we do the sway. So we do the sway mechanism, and I'm going to draw it here. Okay, so this is the sway. So we have got this. That's the sway mechanism, all right? And we have, sorry, it's not really good. Sorry about that. That's the sway mechanism, okay? Because these two are at the same level, okay? And we have got the hinges. What can you say about if the angle here is theta, what can you say about the angle here? Is it theta? What's the angle at the other end? The columns have got different heights. The displacement is the same, okay? The displacement is the same. We have got the same displacement, delta, okay? Delta is 3 theta. It's also equal to 6 beta. And therefore, you have theta is 2 beta, or beta is half theta. So be careful, yeah? So when you've got different heights for the column, the displacement are always the same. When you have got sway, the displacement are the same. But if the columns have got different heights, that means you've got different angles. Right. So we've got theta is 2 beta, or beta is half theta. Is that okay? Now we can do the external work. So we have MP. We have MP, 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 and MP. Okay? Theta and beta here. So we have external work. We have H times 3 theta. Is that okay? Agreed? Equals what? Equals MP theta at A, MP theta at B, MP theta and sorry? Oh, we have 2 MP. That's why I'm checking whether I've got, yeah, this one here is 2 MP. Sorry. Yeah, but at the top, it's MP. Be careful, because the hinge will always form in the weaker member. So if you've got the same MP, if it's okay. If you've got the same MP, it's okay, because that will be at the joint. However, if you've got different values of MP at the intersection of members, the hinge will always form in the weaker member. In other words, when you get to at A, it's 2 MP. However, when you get to point B there, when you get to point B, the hinge will form in the beam in this member here. Okay, so it's MP. Is that okay? Yes. The hinge will form in the weaker member.
I understand that. 2 MP.
Because it's 2 MP, it's given. Given the plastic moment for this member is 2 MP, and it's MP everywhere else. That's given. Okay. Can you write the external work, internal work? Come on, do some work. Carry on, please, and give me the value for H. I've almost finished it. Isn't it? You agree? Yes. This is beta, and this is theta. This is theta. Or 2mp, of course. Okay, now we substitute. Do you agree or not? Yeah. So we have 3h theta, 2 plus 1, 3mp theta, plus 2mp beta. So we have 3mp theta plus 2mp beta. Beta is 0.5 theta. Okay. So we have 3 mp theta. 2 times 0.5 is 1. So we have mp theta. So we have 3, then theta will cancel. So we have 3h. 3mp plus mp is 4mp. And therefore, we have h is 4 over 3 mp. mp, I think mp is given. Yeah, mp is given, sorry, here. mp is 60. It's given, okay? So mp is 60. So we substitute mp here. What load? Because it's a sway. There is no vertical movement. Okay? This point here, CC dash, remain the same level. It's a simple translation, right? Because it's a sway, pure sway. Pure sway, that means it doesn't go down. It's just like this. Okay? Is it 80? So we have 80 for we have 80 for the sway mechanism. Is that okay? Any questions? Any questions? Okay. So now we do the part sway. Same, exactly the same. Okay. You just need to pay attention to the MPs and the geometry. Always. Any questions? Clear? Anyone? I'm here. So if you have anything not clear, please let me know. Okay. Okay, so now we do the combined, the part sway. So now we do the part sway. Okay. This is the part sway mechanism. Okay. So we have got the, as I said, in this case, we've got C to C dash. And if we say the angle here of rotation is theta, we need to find the angle here beta as a function. Okay. So we do what we did last time. We extend the column, extend BC. It gives you a point I, all right? And then we are going to find, to join to D dash and join to C dash, right? So if the angle is theta at B, then the angle at I will be theta as well, okay? And this angle here will also be theta, rotation of the triangle. Is that okay? Yeah. So we do what we did last time. We use similar triangles. I'm going to draw a horizontal line here. And if I call this n, so we have Cn, okay, sorry, In over Nc is equal, so equals ID over dB. Similar triangles. In over Nc is ID over dB. All right. So now we substitute. We have In, Nc. We know Nc. Nc is, what was it again? Was it 4? 4 equals ID. ID is In plus Nd. Nd is 1 divided by dB. dB is 8. Okay. So we have 8 In equals 4 In plus 4. So that means 4 In equals 4, and therefore In is 1. In is 1. All right. And In is 1. That means therefore ID will be In plus Nd, which is okay, 1 plus 1, 2. So ID is 2. ID is 2. Is that clear? From geometry. Yes.
Why is it always like this
Now the pathway is always like this. If you've got the hedge going this way, the part and you've got a vertical, it sways this way.
You put the example to this
Because it's hedge going this way and V like that way, it will sway this way. If hedge was on the other side, with V, then it goes the other way. Okay. Any questions? Any questions? Okay. Okay. Any questions? It's like if someone is pushing you this way, you tend to do this. Yeah, it's the same for the structure. Any questions? Right. So this is now we've got the the distance here, dd dash. So we have dd dash equals was it 8? No, 6. 6 beta, and it's also equal to ID, which is 2 theta. And therefore, beta is 2 over 6 theta, or theta over 3. Or, if you want, or theta is 3 times beta. Is that okay? Yeah. So now we've got everything. We've got the angles. So we need to do the external work. We have V times 4 theta equals, we have MP theta. Let me show the rotations, the moments. This is beta here. Beta. So we have V times 4 theta equals MP theta. This is at A. And look here, the hinge will form in this member. The column has got 2 MP, but the hinge will form in this member. So it's MP theta. Okay. Plus MP theta and MP theta. This is for C. And then for D, we have MP theta and MP beta. So we have MP theta plus MP beta. This is for D, sorry. And finally, for joint B here, joint E, we have MP beta. Now we substitute. So we have 4V theta equals 1, 2, 3, 4. 4 MP theta plus 2 MP beta. Beta is theta over 3. So we have, when you simplify by theta, we have 4V equals 4 MP plus 2/3 of MP, which is 14 MP over 3. Yeah, 14. So therefore, V is 14 MP over 12, which is 14 times 60 divided by 12. And I think 60 over 12 is 5. 5 times 14, 70. Is it 70? Yeah. Thank you. So we've got V equals 70 for the pathway mechanism. Any questions? It's exactly half two. So we're going to have a break, 10 minutes, and then we do the combined mechanism. So I'm going to leave it recording, okay? Thank you.
which I am.
Yes.
The last lecture you said the proof of the vertical displacement that it equals the distance times theta. You said the proof is in a video on Aula, but it isn't the video.
It's in Aula. It's definitely in Aula.
I watched the video of the
The
previous
video
cohort.
or the PowerPoint, one of them. It's there. It's there. Check. I've seen it this morning.
Okay.
I think it's if it's not the video, it's because I always put both. Check the PowerPoint as well, the PowerPoint as well, but it's there. Okay. Okay.
Are you from Algeria? Right?
What do you think?
I think you're Arabic,
Uh-huh.
right?
Yes.
I'm from Egypt.
He's from Saudi Arabia,
No.
No.
Yemen.
No.
Can you guess?
I guess he's from the Gulf area.
No.
No, not
Wallah.
the
I'm his neighbor actually.
أنا محمد
I'm deep.
ليبيا.
من مصر.
ليبيا.
ليبيا.
ليبيا يا اهلا وسهلا. وانت من الأردن.
من مصر.
مصر المحروسه. ان شاء الله متشرفين.
ربنا يخليك.
مش بعيد عليك.
أكيد طبعا.
بينا دوله واحده.
أكيد طبعا.
وانا قربت لك.
جيران.
بالظبط.
اهلا بكم.
مبسوطين إن حضرتك من الجزائر يعني.
بارك الله فيك.
الله يخليك.
بارك الله فيك. كان عندي طلبه كتير يعني من مصر في
أكيد طبعا.
ان شاء الله. لا الحمد لله ان شاء الله.
حضرتك
كان في طلبه
الله يبارك.
اردنيين.
في اردنيين زمان كانوا اكثر عرب من الان. زمان حوالي 20 سنه من قبل كانوا كثير.
لك 20 سنه في ده.
العدد ها انا مده طويله
مدة طويلة ما شاء الله.
من 95
وحضرتك
انا مش مولود في 95.
بالضبط صحيح. ها
حضرتك بتدي برضو اللي هو الديزرتيشن للماستر ساينس ولا
والله
PhD؟
انا الان في
PhD.
لا انا الان يعني السنه هذه صرت نائب مدير مركز ابحاث
ما شاء الله.
بتاع الجامعه الله يبارك فيك.
ما شاء الله.
ف يعني التيتشنج والسوبرفيجن نقصت منهم يعني. فالسوبرفيجن
ما فيش
ما اقدرش يعني
مفيش وقت. مفيش وقت.
مش فارق يعني اخذ طلبه وما اديهمش وقت يعني
صح مش فير.
مش ماخذ طلبه من السنه هذه يعني. بس في يعني ممكن يعني في زملاء اوصيهم يعني مش مشكله ان شاء الله اذا حب يعني في الستراكشرز.
انا كنت بفكر ان انا اعمل ديسرتيشن في الستيل ستراكشر مع جون اولدريتش.
نعم.
فايه راي حضرتك يعني؟
ايه جون كويس، جون اودريتش كويس. في جون اودريتش في
انا حابب حاجه تكون برضو ليها علاقه بالابلايد فاينايت اليمنت اناليسيس.
عندك اديجوكي.
بس هيبقى كونكريت. انا اصلا كنت في
هو كونكريت. نعم هو اكثر شيء كونكريت. ستيل عندك اديجوكي، عندك
في الستيل ممكن اديجوكي برضه.
وفيها ديفيد توجيلي. درسكم ولا لا؟
هو شفناه تي اي لك ما درسنا.
هو ممكن ياخذ اتصل به يعني بعد كويس
في الستيل ستراكشر.
هو يشتغل على الستيل وعلى التمبر وعلى البامبو.
والبامبو
لانه هو من كولومبيا يشتغل عنده باش يشتغل على
الستيل برضه.
يدرس ستيل.
في الطلبه اللي اخذوا عند اديجوكي السمستر الحالي اخذهم موضوع داينامكس.
هو شغله دايناميك اكثر شيء. بس
لو حاجه في الستيل يعني حضرتك ترشح لي مين في الستيل؟
ستيل فيها جون اودريتش.
يعني
في ديفيد تويلو، وفيه مرتضى بدرسكم. مرتضى ممكن حتى هو كويس. يعني عندك 3 4 فيها يعني الفريد ما اعتقدش
لا الفريد كونكريت كومبوزيت.
هو اكثر شيء كومبوزيت. اف
ار بي بالضبط.
هو اللي كان ستيل كنت انا وديفيد بصراحه.
تمام.
احنا في ستيل. فالان انا تقريبا خلاص مش لا الوقت ما فيش. الله يبارك فيك ما فيش وقت يعني. لو ما لقيتوش اي احد كلمني نشوف.
خلاص ماشي خلاص باذن الله.
حاولوا مع غيري.
والله احنا كلنا الشرف لو مع حضرتك.
لا بارك الله فيك. الله يبارك فيك.
الله يخليك.
الله يبارك فيك ان شاء الله موفقين. من المنصوره ولا من؟
لا انا من بورسعيد.
بورسعيد
بلد جميل.
بورسعيد احنا بورسعيد فيها جنود جزائريين مدفونين في بورسعيد.
صح
من ايام
من ايام عبد الناصر وقبل عبد الناصر.
كان فيلق شارك كان فيلق شارك يعني بالطيارات وكذا.
صح.
مدفونين لسه في سيناء.
الله
يرحمهم جميعا. امين يا رب. الله يبارك فيكم.
الله يخليك.
الله يسلمك. تحتاجوا شيء كلمني خلاص ان شاء الله. الله يبارك فيك. Okay, are we ready to start? Okay, so let's finish, please. Okay, so we have we finished the pathway. Now let's do the combined mechanism. Okay, so this is combining the sway and the pathway. Okay, so okay, this is the sway mechanism, and we have hinges at these points, at these joints. So hinge cancellation at B as before. Is that okay? Yeah. So I'm going to use superposition because we proved it before, so there is no point to do it again. So if we say the angle here, theta, can you look at the superposition and tell me what's the angle here? What's the angle using superposition? Come on. Just look at the two. We had beta half theta from the sway. From the sway, we had half. Okay? And then from the part sway, we had beta a third. Yes? So 1/3 plus half is 5/6. 5/6. Is that okay? Yeah. So we have beta is 5/6 theta using superposition. I leave it to you. If you want to check it with geometry to satisfy yourself that you know how to do it, I leave it to you, okay? But it's so beta is 5/6 theta using superposition. I don't have to do all this, thing there, okay? However, it's always, but it's still good to, to show, all right? So this is the combined mechanism. Be careful here. We have 2 MP theta, okay? Be very, very careful. And that's it. Yeah. Once you've got the angles, the job is done, right? So we have the horizontal times the displacement, which is 3. This is 3 here, 3 meters. So we have 3 theta plus V times 4 theta equals, we have 2 MP theta at A, we have MP theta and MP theta at C, and we have MP theta, MP beta at D, and finally MP beta at E. All right, and all we do now is substitute beta by 5/6 theta everywhere and simplify. Is that okay? Okay, so we have 3h theta, 4v theta equals 2, 3, 4, 5, 5 MP theta plus 2 MP beta, and beta is 5/6 theta. I can simplify theta now. 3h plus 4v equals 2 times 5, 10, and 5 times 6, 30, 30 plus 10, 40, 40 MP over 6, which is 40 times 60 divided by 6. So it's 400. Okay. Now, now we are going to draw the the interaction diagram. Are there any questions? Anyone? Okay. So summarize. So in summary, we have for sway, we have V equals, not V, sorry, H H equals 80. For the parts way, we have V equals 70. And for the combined, we have 3H plus 4V equals 400. We need 2 points here. H0 will give me V equals 100. And V0 will give me H equals, sorry, 1, 3, 2. Thank you. So now we can draw the interaction diagram. So we have VH, V maximum, we have 100. So I go for 100 here, 100. So this is 50. Okay, and we have got H, let's say 150, okay? Yeah, okay. So we have H80 for sway. So H80, so 80. Then we have V70. Parts way. And we have the combined, which is this linear expression. So V0, we have H100, so it's this point. And then V0, we have 133. So 50, 1, 2, 3, 4. So 120, 130, around there, 133.3. Okay, that's the interaction diagram. Okay. So same as before, anything inside, safe and unsafe. So it's just a repeat now, okay? It's exactly the same. You always get a similar type of diagram, not exactly, but that's what you get, okay? Combined and RS sway. Can you find for me the coordinates of Q? So that's V70 in here. So 70, 280, 400 minus 280 is 120 divided by 3, 40, I'm guessing. 40? Is it 40? For V70 here, I think it's 40, isn't it? It should be 40. No? So V is, so we have 40 and 70. Part sway plus combined over collapse. Okay, and R, can you check R? We have 80 for H. So you put 80 here, 3 times 80, 240, 400 minus 240, 160, 160 divided, is it 80? Sorry, is it 40? 40, yeah, exactly. So we have 80, 40. Do you all agree? Yeah. And this is sway plus combined over collapse. Any questions? Any questions? Okay. Is that okay? What I would like to show you now is once you've got all the, once you've got the interaction diagram, how do you draw the bending moment diagram for a particular mechanism, for such a frame? All right. So that's the question now, is how do we draw the bending moment diagram for such a frame for a given mechanism and for a given load combination? Have we finished with all this? Everyone has finished with this slide? Okay, thank you. So bending moment diagram. Okay, let's do the bending moment diagram. Shall we do it for all the three mechanisms? Let's do it for all three mechanisms. So I'm going to start with the sway mechanism, then we do the part sway, and then the combined, and show you how to obtain the bending moment diagram in general, okay, without anything, okay? So let's do it for the sway, for first of all. This is the sway mechanism here. Please follow this carefully. This is the sway mechanism, and I'm going to draw the bending moment diagram for this frame here without any specific values for V and H, okay? All right. Now, if you look at this sway mechanism, we know the moment at A is 2 MP. And we know the moment at B is MP. We know the moment at D is MP. And we know the moment at E is MP. The only moment that we don't know is the moment at C. Okay? That's the only one we don't know. And in order, if you want to determine the moment at A, at C, for given values of A, H, and C, you can actually, H and V, you can determine the moment at C by taking cuts, right? So, for example, you can take a cut at B, which will give you the horizontal reaction at A. So you take a cut at B, it will give you the horizontal reaction at B. And once you've got the horizontal reaction at A, okay, you can then take a cut at C, okay, because now you know the vertical reaction here. Sorry, you know the horizontal reaction there. You need to use, you need to take a cut at E as well. At D as well, to get the vertical reaction there, right? And then if you take moments about C, taking a cut, you get the vertical reaction, right? And then you can do the same there. So you get all your reactions by taking cuts. Once you've got all the reactions, it's easy then to take a cut at C and determine the moment. Is that clear? So that's how you will do it. If you are given, if you know the loading, for example, if I give you H50 and say, if we do a sway mechanism, the bending moment for sway, give me a load combination for sway. Give me a load combination of H and V that will give me a sway mechanism. H80, yeah, and any values here for V. Do you agree? Yeah. So if I take, let's say, V equals 10 kilonewtons and H equals 80 kilonewtons, that will give me a sway mechanism. Is that clear, everyone? Yeah. So I can draw the bending moment diagram for this frame for V10 and H80, and I get exactly the value of the bending moment at C in magnitude, the value itself. Is that clear? That's how you would normally do it. I'm not going to do that because, as you can see, there is an infinite number of possibilities. Okay, so I'm going to draw the bending moment diagram for this here in general, without any specific values for C. All right. The one thing that you need to make sure is that you need to make sure that the bending moment at C is less than MP. Okay, is less than MP, right? And you do that, as I said, if you know the specific values for B and C. Anyway, let me do the sway. Let me draw the sway mechanism here. So this is the frame. We have got clockwise 2 MP. Anti-clockwise 2 MP. We have anti-clockwise MP. We have anti-clockwise MP. We have anti-clockwise MP. And this is what we get from the mechanism itself. That's everything. That's the information that we know from the sway mechanism. Is that clear? Now, using equilibrium, we know that the joints must be in equilibrium. So therefore, the moments there must be MP as well. And the moment here must be MP as well in this direction. And that's for equilibrium purposes. Is that clear? Yeah. The moments that we don't know is the moments at C, right? And we don't know the direction and we don't know the magnitude. The magnitude and the direction of the moment at C will depend on the load combination. Is that clear? So all I know is that I'm going to assume that we have a moment MC and a moment MC there. Is that clear? The direction, the magnitude, as I said, depends on the load combination, V and H. Now, how do we draw the bending moment diagram for this? So we have, please follow with me. Tension, we have tension on this side. Do you agree? Then we have tension on this side. Then we have tension at the bottom, tension at the bottom, tension at the bottom, tension on this side, tension at the top, and tension there. Right? Now it's easy because I take the frame now. Two MP, MP, MP. We don't know MC. We assume it's less than MP. MP. Sorry, MC. MP. MP. And MP. And that's the bending moment diagram for this frame. Is that clear? Yeah. And this is how you draw the bending moment diagram for a given mechanism. Okay. Is that clear? And now we're going to do the same for the other two mechanisms to show you again how to do it in this way. Are there any questions on this sway mechanism, please? Anything at all? Any questions? So MC, magnitude, and sign depend on HV combination or HV values. Okay. So let's do it for now for the what is the other one? For the pathway. I'm just looking for the pathway. Pathway. Questions? Anything at all? Any questions? All right, okay. Have we finished, please, with this slide? Anyone? Okay, so let's do the pathway, this one here. Okay, now we're looking now at this mechanism, and we're going to repeat the same thing. Okay, so pathway. This is the pathway. Please follow with me. Okay. All right, this is the pathway. So at B, we have MP anti-clockwise. Anti-clockwise MP. I'm just going to show what we have here. At C, I have MP and MP. Anti-clockwise, clockwise. Anti-clockwise, clockwise, we have MP and MP. Then at D, we have MP clockwise, MP anti-clockwise, MP clockwise, MP anti-clockwise. And finally, at E, we have anti-clockwise MP, anti-clockwise MP. And that's everything from the mechanism itself. Is that clear? Yeah. Then, for equilibrium conditions, this here must be MP at the joint. Okay. So which one is the unknown in this case? Exactly. You see the difference. For the sway mechanism, the unknown was C. Now the unknown is A. And again, to obtain the bending, the moment at A, it will depend on the combinations, on the values of V and H. If you want to do, for example, if you take, this is the pathway here, okay? For example, if I take, let's say 20, okay? If I say 20 kilonewton for H and V 70, that will give me a pathway mechanism, right? And then I can use those values to obtain exactly the magnitude and the sign of the moment at A. But I'm going to do it general without specific values. Is that okay? Yeah, does it make what I'm saying? Does it make sense? Okay, so let's do it. So we have tension there, tension at the top, tension at the bottom, tension at the bottom, tension at the top, tension on the left, on the right, sorry, and tension on the left. Right, now we can draw the diagram. Okay, so we have MP, so we have MP there. MP, MP, MP. Now we join. We don't know the moment at A. We have no idea. It could be that side, could be this side, it could be any magnitude, it could be any sign, depending on these two here. Okay, I'm going to make a guess, and let's say it's this side here. That's MA. Okay, sorry, MA. MA depends on values of H and V. Okay. Is that okay? Any questions? And that's the bending moment diagram for the sway mechanism. As an exercise, if you want to take values for H and V for a sway mechanism, let's say, let's say 10 and 70, you can practice and see whether you can determine MA just by using equilibrium equations. Okay, you can take maybe 2 cuts to get the moment at A. You can try that on your own. Are there any questions, please? Now I have a small exercise for you before we take a break. Can you do the bending moment diagram for the last one, for the combined? I've done it for two of them. Can you do it with a pencil if you're not sure? And then we cover it together after the break. Can you do that, please? We have about 10 minutes before the break, and then we'll take a 10-minute break. Can you do it now, please? Thank you. If you want to work together, that's fine. I hope it's recorded. Your chance to ask any questions if you've got any questions at all, anything that you don't understand. Yeah, do the combine. Oh, because you haven't got it. Okay. So can you do this, please? This is the mechanism. Okay. So what I want you to do, please, for this mechanism, draw the bending moment diagram in the same way. Can I ask you a question? Are you okay that Thursday we do 2 hours? No, before. You've got 2 hours break. You have 2 hours. Shall we do 2 hours? Everyone, unanimous? You can't. You've got 2 hours break.
Okay, I added to the hour we are adding on Monday, 2 hours on Thursday.
Yes. I tell you, because I might have to travel before. And I don't want to get someone to teach you the what I don't cover. Just in case. It's fine. You finish early. The other announcement, I'm going to release the you've got to do the quiz. Yes? It's part of your coursework assessment. For the quiz, all you need is pass it. There is no mark for it in the module. Yeah? All you need is pass it. Okay? So I'm going to release a practice quiz for you to practice on. Very similar, yeah? So you practice on it. I'm going to release it today. At 5 o'clock, it will open automatically. You practice on it. You don't need to prepare anything because there are no hard calculations. It's a lot of them. Most of them are quantitative questions. What are the assumptions of the plastic theory? What does MP means? What is plastic moment? What's that kind of stuff. So you don't need really to revise because it's open book anyway. So you have your notes with you. So I'm going to release it today, and then Wednesday, not this Wednesday, the next Wednesday, you have all day to do it. Is that okay? So you can do it all day until 10 p.m. However, remember it's a 1 hour quiz. So you can log in anytime during the day, but once you log in and you start it, the computer will kick you out after 1 hour, 60 minutes. Is that clear? 90% of the students in the past, they always finish within half an hour. So it's not like a long quiz. Yeah, so 1 hour is more than enough. Because a lot of them are like multi-choice, take the right one, you know. There are a few where you need a calculator for a quickie calculation, you know. So is that okay? So you get practice next Wednesday, because I checked your timetable, you haven't got any lectures. So I want to give you the whole day to do it at your own, you know, wherever you are, and then that's it. I've never had anyone failing it, so you should be able to. Sorry? For 9 a.m. to 10 p.m.
Is it a work?
No, it's a quiz.
It's an online.
When you go to the practice today, yeah, you log in on the link, and then you get the questions, question 1, question 2, question 3. Okay. Is that clear? That's for the quiz. So you will have a practice today. It's open until next Wednesday. On Wednesday, you have the actual quiz, and you have the whole day. You can do it anytime during the day. It's okay. No one should fail it. I've never had anyone fail it. It's very, very. All you need is get half of the questions right. That's all. So it should be a piece of cake. Is that okay? Yes. Yeah. It's open today. You can do it, and you can the practice quiz today. You can do it, and I will leave it open so you can repeat it. You can do it as many times as you want. It will tell you. Well, when you finish, it will tell you which ones you did wrong. It doesn't give you the answer because I want you to practice. So you can do it. So it tells you, oh, this is wrong. You don't know what's wrong, so you do it again. Is that clear? Yeah, that's the idea. And Thursday we start 1 o'clock. This Thursday, we do 2 hours. We will be in. No, I'll tell you. One o'clock will be 101. This room. So Thursday we are in this room. Is that okay? 1 o'clock. Yeah, because you have 2 hours break. I think you finish at 12. Okay. Thank you. Any questions? You have a question? Thursday, you have lectures anyway. You are coming here. You got lectures Thursday. Really? Oh. Really broken? What time is your? Yeah, we start 1 o'clock. Should be fine. You have to travel. Is it far? CD4. Where's CD4? Okay. Do you want the Thursday one? We do 2 hours online. It's up to you. Yes? Yeah. It's like me physically. So you can ask the question, you can do everything. It's okay. I will send you the link for the channel. So Thursday we do 2 hours. You have no excuse now. Yeah? So we do 2 hours Thursday online. So you can sleep until 12 o'clock. I know you. Okay. It's okay. Only this Thursday. Only this Thursday. So we do it online. I'm going to send you the Teams link, right? So we do 2 hours. You can still interact and ask questions, except that it's online. That's all. But that will be here, not in this room. I will be in my office. So we do it online. Are you all okay with this?
Yes, sir.
Yeah?
Yes.
Okay, thank you. Yeah, sorry. Don't worry. I will change them manually. I've done it last time, so don't worry. Yeah, okay. So be ready Thursday for a Teams lecture. Thank you. Right, it's 2:30, so we're going to do a break, and then we do this question together. Is that okay? Thank you. Everybody, I didn't want my question. Next. Okay.
Talaga Linden, Julie. Linden nasıl?
Okay, right? Okay, let's do the bending moment diagram for this, for the combined, and we are finished with this one. So combined. All right. Now see here, we've got clockwise. We've got anti-clockwise 2 MP, anti-clockwise 2 MP. Then we have clockwise on the right and anti-clockwise there, MP. So we have MP, MP. All right. And then we have MP clockwise, MP anti-clockwise. Clockwise, anti-clockwise. And finally, we have anti-clockwise MP at E, anti-clockwise, anti-clockwise MP. And these are the moments from the combined mechanism, okay? Now, the ones that we don't know in this case is the bending moment at B. That's the unknown one, okay? So we have, can we have some silence, please? So we have tension on this side, tension at the bottom, tension at the bottom, tension at the bottom, tension on the left, and tension on the left. Oh, sorry, I made a mistake. This is actually clockwise and anti-clockwise, sorry. Clockwise, clockwise, sorry, anti-clockwise. Sorry about that. So we have clockwise, anti-clockwise, okay, from here. So we have tension at the top, tension on the right. Is that okay? So let's so the unknown moment this time is this one at B, okay? So let's draw the diagram. Okay, so we have 2 MP. We have MP, 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 and MP. We don't know the moment at C. Yeah, again, it depends on the H and V. So I'm going to assume that we've got values like here, for example, MC, MB, sorry, and MB, MB. And that's the bending moment diagram. Is that okay? Yeah, so that's the bending moment diagram. Again, you can check MB for different values of H and V to practice on how to obtain it. equilibrium equations. Okay, so we've covered this example from A to Z, okay, with the mechanisms, with the interaction diagram, and also how to obtain the bending moment diagram for any particular mechanism. So you should be able to do that for any pitch roof frame like this. Any questions? Okay. All right. Are we done with the with this slide, please? Yes. Okay. Thank you. I'm going to scan them and put them on Moodle. Okay. So if you miss anything, don't worry. Any questions? Okay. Okay, I'm going to stop the recording because I would like to start something different.